When we see artificial intelligence generate a complete digital world in the blink of an eye, it feels like magic. Looking at this interface, it is easy to assume the model has a natural understanding of human politeness or the specific silhouette of a pedestrian. But algorithms have no innate concept of the physical world. When an AI fabricates a fact or makes a bizarre error, it is often because it lacks a structured baseline of reality. Think of an algorithm as an empty mechanical engine. To produce results, it requires massive amounts of human-engineered fuel. Careers in this field do not always require writing complex code. Real influence belongs to those who control the high-quality data that feeds the engine. To understand how we control these systems, we have to look past the modern chatbot and examine the raw mechanics of machine logic. Large language models do not process whole words. A sentence is sliced into fragments called tokens, passing through billions of adjustable logic nodes, the parameters. We guide these parameters through prompt engineering. The RCTC framework, role, context, task, and constraints, organizes chaotic tokens into a useful response. Advanced techniques like chain of thought force the algorithm to reason through a problem step by step, mimicking a logical sequence rather than jumping to a statistical guess. Immense processing power provides the speed, but human intent provides the steering wheel. But how does an algorithm actually learn to safely navigate the highly unpredictable movements of a busy urban intersection? It requires a ground truth, the standard of reality explicitly defined by humans through data annotation. Looking at this chart, you can see preference ranking in action. Humans score raw text data to teach the model which responses are helpful and which are harmful. This human feedback also drives visual perception. We draw bounding boxes around alt text so the machine recognizes a stop sign or a cyclist. For spatial perception, autonomous vehicles use hardware like this LiDAR sensor to capture 3D point clouds, allowing the model to calculate depth and distance. This is a rigorous engineering workflow. Teams use double annotation and arbitration to ensure the data is accurate before it ever reaches the model. Without this human-defined structure, a self-driving car cannot reliably tell the difference between a dark shadow and a solid concrete barrier. There is a common concern that these algorithms are being built to replace human workers entirely. However, the most productive results come from Centaur intelligence, the symbiosis of human judgment and machine speed. Modern annotators do not manually label every single pixel. They work with the AI, using semi-automatic tools and active learning to scale their productivity. Mastering the logic of these data edge cases provides the technical foundation needed to move into roles like data strategist or AI project manager. The algorithm still relies on humans to evaluate safety, detect subtle bias, and audit its ethical boundaries. You can choose to compete against these tools, or you can learn to orchestrate them. The Data Annotation Associate Bundle provides the pathway to mastering these specific, high-demand skills. The AI revolution is built by the hands that define its reality. Are you ready to begin?